In this video, we want to find the limit as n approaches infinity of log base 2 of n plus 2 to the n over log base 3 of n plus 3 to the n. The key to solving this is to factor out a 2 to the n and 3 to the n from the top and the bottom. So in the top, if I factor out a 2 to the n, I have to divide log base 2 of n by 2 to the n. And then we have a plus 1. And then for 3 to the n, I have to factor out I have to divide by 3 to the n for log base 3 of n, because the 3 to the n's are going to cancel, and they have plus 1. Now I'm going to break this up into two separate limits. We have 2 to the n over 3 to the n, which I can factor out the exponent and just have 2 over 3 raised to the n. And then we have the rest here. Notice that 2/3 to the n is geometric with ratio less than 1. So the absolute value of the ratio is less than 1. Here it's 2/3. So we know that this limit is going to go to 0. Now with this limit, we know that an exponential is much stronger than a log. So 2 to the n is going to infinity faster than log base 2 of n. And so this is going to go to 0. And the same reasoning for this fraction, that goes to 0. So we have 0 plus 1 over 0 plus 1. That's going to be 1. And we're going to multiply that by 0 from the first limit and get that our limit is 0.